In this demonstration, we dropped a 220-pound mannequin only 6 feet. When the mannequin hits the bottom of its 6-foot drop, you can see the violent forces at work. Now, look at the difference when you incorporate a shock-absorbing lanyard. The forces on your body have dropped from almost 5,000 pounds to less than 900.
Hey John, are you ready up there?
Yeah, let's do it.
Okay, bring it up 12 inches and west 70 feet. You're clear, John. You can bring it in. That's good. We have it.
Hello, my name is Mike Sullivan, and I'm here today to help you think about fall protection. Did you know that during the last decade, over 500,000 workers just like you were seriously injured due to falls from heights, and over 6,000 of them died? By understanding fall protection principles, you can greatly reduce your risk of a fall. This video will give you a fundamental awareness of fall protection, what you absolutely need to think about before you can work safely at height.
Excuse me? According to industry standards, you're considered to be working at height if you're at 4 feet in general industry or 6 feet in construction.
Well, thanks for your input, Harness Man. Feel free to drop in and see us again. That's a good point. When you're at height and at risk of falling, we all must use some form of fall protection. Remember, the term fall protection encompasses everything we do to protect someone while at height. And there are many different types of fall protection systems to consider. From horizontal lifelines to vertical climbing systems, basic fall restraints to self-retracting lifelines. All of these fall protection systems are designed to fill specific needs. It's also important to know the difference between fall prevention and fall arrest. Whenever possible, we should put in place a fall prevention system that eliminates the possibility of a fall altogether. This could include engineering out the hazard, like moving a valve to ground level, or simply installing guardrails. But if a possibility of falling still remains in your work environment, you need a fall arrest system, a system that brings you to a safe stop when you fall. And no matter which fall arrest system you use, they all require some fundamental considerations. This is where we'll focus our discussion. Your fall arrest system must include the following components: your harness, what you wear; connectors, what's attaching you to your anchorage; the anchorage. Your anchorage is the structure you're attached to; and of course, a rescue plan.
When you set up a fall arrest system, there are several things to consider. These are arresting forces, which are forces generated on your body and the system when you fall. Required clearance, which is the distance you must have between your work platform and the nearest obstruction below you. And swing fall, which is the pendulum-like motion that can occur when you fall.
Let's begin by looking closer at arresting forces. The actual forces generated on your body and the system when you fall. In this demonstration, we dropped a 220-pound mannequin only 6 feet. When the mannequin hits the bottom of its 6-foot drop, you can see the violent forces at work. Let's take another look in slow motion. The amount of force generated on that 6-foot drop is measured at almost 5,000 pounds. That's more than enough force to cause serious injury.
Say, just for your information, 5,000 pounds of force exceeds regulations. The maximum arresting force allowable when using a full body harness is 1,800 pounds. Are you going to explain how we can reduce those forces to below 1,800 pounds?
I'm going to do that, Harness Man. But first, let's deal with two very important considerations in setting up your fall arrest system. They are total fall distance and swing fall. In order to calculate your total fall distance, you first need to consider your free fall. Free fall is the distance you fall before your fall arrest system begins to slow you down.
Tell me, Mike, can you state the rules that relate to free fall?
Sure, harness man. The rules say that fall arrest systems must protect you from contact with any lower level or obstruction, with generally no more than a 6-foot free fall.
So, you're saying if the lower level is more than 6 feet below, all we need is a 6-foot lanyard and we're good to go?
Well, no. There's more to it than just the length of your lanyard. The location of your anchor point plays a big factor in determining your free fall and your swing fall. Let's take a closer look at what we're talking about. If you're using a 6-foot lanyard connected to the dorsal D-ring of your body harness, and you connect the other end to an anchorage point at the same height, how far will you free fall? In this case, you'll free fall 6 feet, because that's the length of the lanyard that's connecting the 2 points together. However, how far will you free fall if you're connected to an I-beam 4 feet below your dorsal D-ring? In this case, you'll see a free fall of 10 feet. That's 4 feet to the I-beam plus the 6 feet of lanyard. Here you'll have exceeded the typical 6-foot free fall.
So, is it safe to say that if we anchor ourselves at shoulder height with a 6-foot lanyard, we won't hit any obstructions below us if we fall?
Well, no, I wish it were that simple, but there are still other factors that come into play. Free fall is just the first component of our total fall distance. To determine whether we have enough clearance below us, we must add our free fall distance plus our deceleration distance, the distance it takes for our system to slow us down and stop us. During deceleration, the system makes use of a shock absorber that will dissipate energy as it tears open and stretches. This process of slowing us down increases the length of our total fall distance. Regulations state that the deployment of a shock absorber may add a maximum of 3.5 feet to our fall distance. In addition, as we decelerate, our D-ring will slide up on the harness, and our body will form into the harness. This will add 1 additional foot to our deceleration distance. In total, deceleration adds 4.5 feet to our total fall distance. So, in this application, our total fall distance is 10.5 feet. And finally, we need to add a safety factor. The safety factor that we often use is 2 feet. Now we have our required clearance, the clearance we must have below us in case of a fall. It totals 12.5 feet when using a 6-foot shock-absorbing lanyard connected to our dorsal D-ring and anchored at shoulder height.
So that all makes sense. Is that all we have to consider?
There's one more thing to keep in mind. We need to position our anchorage point directly above us whenever possible to reduce the risk of swing fall. A swing fall can occur when you position yourself to the side of your anchorage point. In the event of a fall, your fall arrest system will stop you. However, due to the angle, you'll swing like a pendulum, potentially striking any objects in your path. The greater the angle from your anchorage, the wider your swing fall will be. And swing fall can cause serious injuries.
Well, now we understand how to calculate our required clearance and the concept of swing fall. Are you going to explain the actual components of a fall arrest system?
Yes, I am, harness man. In fact, let's start with the body support. First, a full body harness is a must if you're working at height. Not only are they required as part of the fall arrest system, but full body harnesses have pretty much replaced the use of body belts in most fall protection applications. Belts are recommended for use in travel restraint applications only, but a full body harness works well there too. With a full body harness, we're able to protect the body by distributing the fall arrest forces over the thighs, buttocks, chest, and shoulders. When donning the full body harness, it must be adjusted to fit you properly. It should be snug but comfortable. The subpelvic strap should be positioned directly under the buttocks. This strap and its proper placement are crucial. It is the subpelvic strap that dissipates much of the energy generated in a fall. The chest strap must be fastened securely, and the dorsal D-ring should rest between your shoulder blades. Once your full body harness is properly fitted, you'll get freedom of movement, comfort, and maximum protection in a fall. Now, let's think about connecting. A variety of connectors are available to couple your system together. They include such hardware as snap hooks and carabiners, as well as soft goods such as lanyards and shock absorbers. Let's look closer at the snap hooks and carabiners. They're available in a wide variety of shapes and sizes and must all be self-closing and provide a locking feature to help reduce the possibility of rollout.
I would just like to say that non-locking connectors do not meet regulations for use in fall protection.
That's right, Harness Man. And even locking connectors can still roll out or disengage if not used with compatible hardware. Like connecting two snap hooks together is not safe. See that? Or using incompatible sizes. Make sure you always use a D-ring that is larger than your snap ring to prevent forced rollout. And one more important fact about connectors, the standards. Would you like to tell them, Harness Man?
Yes, I would. As a general rule, all connecting components and assemblies must have a minimum strength of 5,000 pounds.
Well, there's that 5,000-pound figure again. Even when part of a shock-absorbing lanyard, a connector must be rated at 5,000 pounds. Let's talk for a minute about lanyards. They're used to connect your body harness to the anchorage point. They're made of rope, webbing, or cable. When used for fall arrest, they must include a shock absorber. Here's why. As we saw earlier, a 220-pound, 6-foot drop generated almost 5,000 pounds of force on the mannequin. Now, look at the difference when you incorporate a shock-absorbing lanyard. The forces on your body have dropped from almost 5,000 pounds to less than 900.
Well now, wait a minute. Regulations only require us to limit a maximum arresting force to 1,800 pounds. You're saying we can achieve less than 900 pounds using a shock-absorbing lanyard. Does this mean we can decrease our connector and our anchorage ratings down to 900 pounds?
No, that is not right. Things like snap hooks and carabiners still must meet the 5,000-pound rating. Something else to consider with lanyards. Never tie knots or run them over sharp objects. This will greatly reduce the strength of the lanyard. Vertical mobility with lanyard connectors is something else that's important. Since most lanyards are only 6 feet long, they may not provide you with enough vertical mobility to do your job. Rope grab and vertical lifeline systems, or self-retracting lifelines, are other types of connectors that allow you to have greater vertical mobility along with added protection. The most important thing to remember with connectors is to stay connected. If you're not connected, you're not protected. The final component to your fall protection system is the anchorage point. Some examples include structural steel members, precast concrete, or wood trusses. Do you know what the strength requirement of an anchorage point is?
I do. If it's not an engineered system, an anchorage point must be able to support a static load of 5,000 pounds for each person attached to it. So that's 10,000 pounds if 2 people are attached. But I have a question, Mike. How do we know what an anchorage point is actually rated for?
If an anchorage point has not been certified by a professional engineer, then we don't know. So if you need to use an anchorage point that is not certified, ask yourself, is that anchorage point able to support at least the weight of a full-size pickup truck? If you don't think so, don't use it. Now, with that in mind, some obviously inappropriate anchorages would include fluid-carrying pipes, electrical conduit, or handrails. What if someone on your crew does fall? What do? Anytime a worker is at risk of a fall, you must have a plan to safely rescue them.
That's right. According to industry regulations, the employer must provide for prompt rescue of employees in the event of a fall, or shall assure that employees are able to rescue themselves.
Yes, you must have a plan, and our plan for rescue must be reviewed and practiced on a regular basis. It's also important to remember that the rescue should be kept as simple and safe as possible. If calling 911 is your only rescue plan, then you must ensure that your local rescue professionals have the equipment and training required to perform your rescue. All your fall arrest equipment needs to be properly maintained. You should personally check all your components before each use and have an annual inspection performed by a competent person. While checking your equipment, be sure all the hardware is free of cracks, burrs, or corrosion, and all the working parts move freely, including the buckles and snap hooks. Be sure that all the plastic pads and keepers are in place and free of cuts or cracks. The webbing and rope should be free of any cuts and frayed or broken fibers. Check for tears, abrasions, burns, or discoloration. All the stitching should be intact. Check for pulled or cut stitches. Broken stitches may indicate that the equipment has been impact loaded and must be removed from service. Inspect all the labels to see that they're present and fully legible. If the labels are not, they should be replaced.
Upon final inspection, record the results and date in an inspection log. If the inspection reveals any defective component, remove it from service immediately.
We've covered a lot of information here today, so let's highlight what we talked about. Anytime workers are exposed to the hazard of a fall, they must be protected by a fall protection system. Remember, the term fall protection encompasses everything we do to protect someone while at height.
And working at height means 4 feet or more for industrial applications and 6 feet for construction.
If the possibility of falling exists in your work environment, you need a fall arrest system. A system that brings you to a safe stop with 1,800 pounds or less of arresting forces. A fall arrest system will have 4 components: an approved full body harness, connectors, including lanyards, shock absorbers, self-retracting or vertical lifelines, and rope grabs, anchorages. Only suitable structural connection points should be used as an anchorage, and they must be capable of supporting 5,000 pounds per worker attached. And finally, a rescue plan. Always have a rescue plan.